اقرأ فإنك ذو نسم، ليس الجهول كمن علم. اقرأ فإنك ذو نسم، ليس الجهول كمن علم. اقرأ بأول آية نزل الكتاب المحتك.
Hello, class 9 of CIS School, City International School. We are welcome. Stay at home and we will bring the lesson to you. Don't worry about it. So we will start now from Unit 5. Unit 5 about the circle. So we must know what is the definition of circle, what is the radius, chord, the diameter, and the relation between the circle and the line. Between the circle and the line, and between two circles together. This is the pre-lesson of what? Of the circle of Unit 5. Let us first take the circle. This curve, closed curve is called what? The circle. So let us find the definition of the circle. The circle is a set of points moving from fixed point. So, the definition of the circle is a set of points moving from a fixed point. So the fixed point is called the circle. The fixed point is in the center of a circle. The fixed point is called the center of the circle, and always denoted by what? By capital M or O. You can choose any letter for what? For the circle. Also, we have the distance, a line segment M. C is called the radius. So, MC is called the radius. What is the radius? The radius is the line segment from the center to any point on what? On the circle. To any point on the circle is called what? The radius. And also we have M. If I produce the line from CM to D, so CD is called diameter. And it denoted by small d. So we have a radius, it denoted by a small r, and CD, the line segment CD is called what? The diameter. Let us take the relationship between diameter and radius. The diameter D is twice the radius, 2 multiplied by r. Then if you want to find r is equal d divided by what? Divided by 2. So the radius is half of what? Half of diameter. Half of diameter. Also, I have another line segment, AB. The line segment AB is called chord. The chord. AB is called the chord. The chord of the circle. So definition of the chord, any line joining two points on a circle. Even if this line is what? Is a line segment is diameter. So the diameter is the biggest chord in what? In a circle. Diameter is biggest chord in a circle. So these are the most important of line segment in the circle. If the line cut the circle, for example, by green line. So this line is called what? Transversal. It's called transversal. line L. The line L is called transversal. So this is simple about what? About the circle. Also, let us take the point and the circle or the line. For example, if we have a circle of center M, and always the circle is named after its center. If the center O, you can say the circle O. Center M, you can say the circle M. So if there is a point, for example, A, and here there is another point B, and there is a point here is what as C. So these 3 points, the point A is inside the circle. And the point B is on the circle. But the point C is outside the circle. So 3 points of any circle. So the point may be inside the circle or outside the circle or on the circle. Outside the circle or on the circle. Also, there is another relation with the line and the circle. Line and the circle. I mean the relationship between the line and the circle. If we have a circle, there is 3 lines. You can take the line, the first line, this line is outside the circle. And this line, which does the circle here. And there is another line, maybe it cuts the circle. So, the first line is situated outside the circle. And this line, transversal, and this line is called tangent. Tangent of the circle. So the tangent of the circle is a line which touches the circle at one point, and this point, for example, A. So the point A is point of tangency. Or are called what? A point of tangency or contact point. Point of tangency or contact point. This as a revision of what? So as to get the circle and the relationship of what? Circle with another shapes. A circle with another shape. Let us say we have in Unit 5 about 13 or 14, 13 units. 13 theorem actually. So as we said, the theorem is contained of what? Of 3 parts. Any theorem. The theorem is contained of a statement. What I mean by a statement, if there is, for example, a line from the center of the circle to any point. So this is said to be as a statement. Any theorem, it has a statement. Also, if you want to prove any theorem, you must draw the figure of that theorem. Without drawing the figure of theorem, you cannot prove the theorem. So the figure is the main point if you want to prove the theorem. After that, we have 4 points or 4 steps you should do it. The first one, you should find out what is given. From where did you get what is given? You can get what is given from the statement of the theorem. From the statement of the theorem, you can take what is given. After that, you have to find what is required to prove. You are going to prove what? So, which is TRP. What required to prove? Required to prove. The third one, you must do construction. We mean by construction is a work. You have to do it in the theorem so as to be clear for you to prove it. So theorem with figure, it is not easy to prove it directly. So you have to do something on so as to prove the theorem. After that, the last step is prove the theorem depending on the 3 steps before. Depending on 3 steps before. Let us take the first theorem, for example. So as talk live. Theorem 1 is the line drawn from the center of the circle point of the curve is perpendicular to the curve. So this is the statement of the theorem. The line drawn from the center of the circle to the midpoint of the curve is perpendicular to the curve. This is called what? The statement of the theorem. The statement of the theorem. Now from the statement there are some important figures. For example, I have a line, and this line is drawn from the center of what? Of the circle to the midpoint of what? Of the curve is a new word is perpendicular to what? To the curve. Perpendicular to the curve. Now, from this, this is a statement. Now, you must draw the figure of this theorem. It has a figure. So, according from the statement, you can draw the figures. It means we have the line drawn from the center of the circle. So, I have a circle M. This is circle what? M. The line drawn from the center of the circle to the mid of the curve. So you must draw the curve AB. AB is the curve. Okay? Now the line drawn from the center. This is the center. You must draw the line from the center to the mid point of what? Of the curve. Up to C, MC. It makes AC equal to what? To CP, to the midpoint of the curve. It's perpendicular to the curve. So simply, this is the figure of what? Of the theorem. This is the figure of the theorem. How to prove it now? That is step 2. So any theorem, it contains a statement. If you want to prove it, you must draw the figure of that theorem. After drawing the figure, you must find the 4 steps. The one is given. What is given? So if you want to find out what is given from here, the first 2 or 3 lines from this step. The line drawn from the center of the circle. So I have a circle M. A circle M. What is in the circle M? I have AB is what? A curve. AB, a curve. Okay, we have a line MC. It divides or bisects the curve AB into 2 equal parts. MC is a line drawn from the center. So, which gives us what? AC is equals to CB. So this is enough for what? For the given. What is given? Given that we have a circle M, what is in the circle M? In circle M we have AB is a curve, and I have a line MC, this is a line segment. This line segment is divide or bisect the curve AB into 2 equal parts. Okay, this is the first one. The second one, required to prove. You are going to prove what? How to find out what is required to prove? Look at the last statement, the last word. So, of the car is perpendicular to the car. Translate this into math symbol. How to is perpendicular? What is perpendicular to the car? I have MC is perpendicular to the car A, B. This symbol, it means perpendicular. The symbol of perpendicular of the. So MC is perpendicular to what? To write down it perpendicular. So this is simply required to prove. Now we can take the third one, construction. I mean by construction is a word. This one does not change the figure, but it helps us to prove the theory. Does not change the figure. Now the work is join M-A and M-C, M-B. Join M-A and M-B. So, the work always, you have to do it as a dot line. As a dot line. So that bring a new thing. Now, according to this, we have two triangles. This one triangle and this is the other triangle. Now we will take the last step is how to prove this theorem. P-R-O-O-F. Proof. Last, you should know why this theorem is correct. You must find out what is required to prove MC is perpendicular to A, B. Okay, to prove, if I have two triangles, you should check that the two triangles should be congruent to each other. I mean by congruence of two triangles, I gave you before a lesson, revision lesson to show you the properties of congruency of two triangles. And congruency of two triangles, if there exist three sides, which is denoted by SSS, or two sides and there is an angle between them, SAS. Or two angles, one side, or right angle, hypotenuse, and one side. These four properties of congruency of any triangle. I mean by congruency, it means typical to the other. So if I have two pens, this pen is congruent to this pen, with same shape, same of element. So this one is congruent to this one. So you can compare between the two triangles. Now, to prove, you should take the two triangles in triangle AMAC and triangle MBC. Let us find out what are equal in these two triangles. I take this one, MAC, MBC. What is given in these two triangles? It's given that here, AC is equal to what? CB. So write here AC equal to CB. It's given. Okay? Also we have another MA, M equal to MB. A equal to MB. Y equal to MB. And MA is the radius, MB is the radius. All the radius inside that circle are equal. So MA equal to MB. So the plural of radius is radii. Two radius are radii. So let us find out an angle or another side. So there is another side, one side, MC is joining the two triangles together. So MC is said to be what? Common side. So MC is common side. Okay, now you can take a conclusion. According to the three sides, I have AC equal to CV, it's given, MA equal to MB radial, and MC is what? Common side. So, now you can decide. You can say that, therefore, triangle MAC congruent to triangle MBC. So these three lines underneath are said to be what? Congruent. Why the two triangles are congruent? Because of what? Of three sides, SSS. 1, 2, 3 sides. Because of three sides. So the congruency of two triangles. So triangle MAC is congruent to triangle MBC. Therefore, from congruency, you can find out here, what about this angle? ACM is straight angle. Why do you know that any straight angle is measured out up to what? 180. Straight angle is 180. So the measure of angle ACM, which is straight angle, is equal 100 to 180. Since measure of angle MCA equal to measure of angle MCB, so each one it should be equal to 90 degrees. Why? Because this angle is equal to this angle. So the total of this angle is 180. So when you divide 180 by 2, you will get 90 for each one. So it's 90 degrees. Since it's 90 degrees, therefore, line MC is perpendicular to AB, which is what? Proved. If it's 90 degrees, so it's perpendicular to which?
اقرأ فإنك ذو نسم ليس الجهول كمن علم. اقرأ فإنك ذو نسم ليس الجهول كمن علم. اقرأ بأول آية نزل الكتاب المحتمل.